All right. Afternoon all. All right. Compliment for the new year. Yes. So we are actually starting with some past question papers. You are making noise. Yes, those that are online. Afternoon then.
Afternoon, sir.
How are you guys? All right, so we will actually look at some questions from past question papers. We will look at, we'll be jumping up and down, okay? So we had some changes, and yeah, as you can see, this is actually paper 4. There are some important questions that we need to look at, but we know that this is actually the old curriculum, and we are doing the new curriculum. It's just that they have added some of the things and they have removed some of the things. We just want to make use of these questions here, so that we see as to how the questions are being set, right? So those that are online, are you guys hearing me?
Yes, sir.
Yes, sir.
Hi, yeah, zoom in. I'm not, maybe I zoom in. All right, so it is actually a theoretical question. It is a theoretical question. I felt like we should look into algebra, log, sequence, and probabilities. Actually. Yeah, because it's a long question, we are just trying to do some question papers, not just teaching anymore. Okay, so yeah, should I go down? Yes. We will have a look at that. Okay, we'll have a look at that. So we will do it. I believe we have done it on not online, but face to face inside of our. So just have a look at it. Yes, it says simplify. Have we done this one? I don't think so. Okay. All right. So when you look at this question, what are you going to do? It says simplify. So, yeah. Yeah. What are we going to do? All right. So we are going to factorize. When they say simplify, definitely it is a fraction, and therefore we are going to factorize. Are we together? So the numerator, you need to look for the common factors. Right? For the numerator, is not difference between two squares, not at all. Okay. And the denominator, when you look at it, is not. It is quadratic, but it's quadratic with various variables, right? With different variables. Therefore, the denominator is going to be factorized by grouping, is it? Yes, okay. And therefore, yes. And therefore, if we are to factorize the numerator, what is common? What is common then? Okay, it definitely is x. Therefore, we are going to remove x. Okay, and therefore x to the power 3 divided by x is going to be what? So it's going to be x squared. Okay, so that one will be x squared, and then x multiplying y squared divided by x is going to be what? So this divided by that is going to be, so it's just going to be y squared. Okay, and then definitely you divide. Now you are going to factorize the denominator. Okay, you are going to factorize the denominator. So therefore, you are going to factorize this by grouping and basically is it? Yes, right. So what is common between the first two terms? It's just x. Okay. Therefore, you are going to factorize out x, and then you have what? You will have x, that is correct, Minus what? Minus 3, yes, okay. And then the next one, what is common in all of them? It's actually y. So it's actually y. So we are going to remove y there, okay? So it will be plus y, and then you have what? So this one divided by this is going to be 2x, and therefore again this divided by y again is going to be what? Minus 3, okay? So you can already see whatever is in the parentheses is actually the same. The first and the second parentheses, basically they're actually the same. So it's only going to be represented once. The first one will be x, this x, and this will form a bracket there. Okay, so plus y. My apologies for that. I need to work on the numerator there. Are you guys sleeping already? Right. Okay, so right. But again, when you look at the numerator, it can be further factorized, isn't it? So when you look at this, is difference between two squares. This is actually difference between, can be factorized by difference between two squares. Okay, because these are even numbers and the sign in the middle is a what? It's a minus. Okay, as long as those ones are even numbers, the power is basically evens, and the sign in the middle is a minus. That's why they are saying difference between two squares. Ne? So you have to factorize that one further. Okay, so the x will stay as it is. That one will be x, and therefore, when you are factorizing by difference between two squares, you are only going to apply a square root there, the square root there, and then you have plus or minus there. So definitely one of them will be x plus y. The other one will be what? X minus y. Okay. So that one now is fully factorized. Okay. So you divide by what? You divide by whatever you have under there. Okay. So you're having x, and then you have what? Okay, so that one we just need to write it directly. Okay, so we don't need to waste time anymore. I believe now you can see that. Okay, so yes. So therefore the down one will be x plus what? Plus y. Eh? So x plus y, and then also this one is actually repeated. Therefore we are only going to take one of them. Eh? 2x minus 3. Okay? So these questions are coming in the exam. They are coming in the exam because I'm sure that they are coming in the exam. Are we together? Yes. Yes. Okay. So just know that they are going to ask you to factorize. All you need to do when you are factorizing a fraction, a single fraction, it means something in the end is going to cancel out. You need now to bear in mind when you're factorizing, we have about 3 of them. So difference between two squares, common factors, and also what grouping is just like that. Something is going to cancel out in the end. Okay, so you should be able to know that. All right. Now, when you look at this, yes. So what is going to cancel out there? So it's going to be x plus y. Therefore, these will cancel out with it. Okay. So what is remaining is just what? Now, what is basically remaining is just x, and then x minus y, and then the down one is actually what? 2x minus 3. Okay. So that is basically it. That is basically it. Therefore, you are having your x minus y over 2x minus 3. Okay, minus 3. Sometimes when they say simplify, when you look, if you see a single fraction, you are going to factorize. But when they say simplify in the other way, they are going to give you some terms and then you collect them out together. But when it's a single fraction like that, you definitely have to factorize out some of the things. Okay. I believe on logs now we should be fine because, okay, no, it's okay. So they are saying express 2 log x minus 3 log y minus 2 as a single log. Ne? So it's a single log. I have to give you the rules again before you start. You need to know the rules. Okay. So we are having now so I would like to write for you the laws of logs on this side. Okay. So suppose that you have log A plus log B. Okay. So when you are adding, what do? You multiply. Okay. So you basically multiply. This is going to be log what? Log A B. Okay. And then the next one, when you subtract log A minus log what? Log B is going to give you what? When you subtract, you divide, it's going to be log A divided by B. And then we have what is called the power law. When you're having log A to the n, is actually what? It's actually n log what? N log A, okay? So it's basically that, né? So you should be able to know those rules, okay? Now, when you see the first one, we have to apply what? We have to apply the power law, né? That therefore you are going to bring this one on top, okay? So therefore that one will be log x to the 2, okay? So, or x squared, that is actually it, okay? And then the next one is the same, isn't it? So it's going to be minus log y to the 3, okay? So y to the, come again? Yes. It doesn't matter if you go negative. No. It's fine in this case. In this case, you are not going to take the negative there because you want to apply the laws of what? The laws of the product law and the quotient law. Are we together? So I would not want, remember logarithms and indices, they go negative. So you would not want people to work with negative logs, which you do not do. Are we together? Okay, so therefore the negative is going to be there in order for you to apply what? The quotient law. It's going to be there in order for you to apply the quotient law. That is actually it, okay? So now the other thing you should know as well is common logs. Common logs. For example, when you're having log 10 is actually 1. And then log 100 is actually 2. So log 1,000 is actually what? 3. I advise you to know the first 5 actually. So you need to know those ones. But you should not even memorize these things. Do you know if they give you 2 there, it means it's having 2 zeros altogether. So there are 2 zeros there. If it's actually 1, it means that there is a 0 there. Okay, and if it's 3, there are 3 zeros. Okay, so you just need to know that one. And therefore, minus log what? Minus log 100. Oh, sorry for that. Is it 1,000 or 100? It is 100. Okay. Yes. No. That is a lie because yes, those that are online, are you guys hearing me?
Yes, sir.
Wonderful. All right. So I have seen that common mistake. Are we together? People they are saying log? You are now saying log 2. Where there is what 100. You say that? Yeah. People are saying log 2. Log 2 is also equivalent to a number. Remember, we did not even start at 1. We did not even start at log 1, we started at log 10. Okay, log 1 is some 0.0 something. Then log 2, yes. So then log 2, log 3, log 4, log 5, log 6, log 7, 8, 9 to 10 all together. So log 2 is not the same thing as 100, not a 1,000. See? It also has its own number. Right. Yes. And do not apply the laws of logs if you are not working with all logs altogether. There is no way you will say this divided by 2. No, only if it's log altogether. Therefore, you need to apply the rules correctly. Okay. From there, we are going to we can work out this first, né? Okay, so that is actually the question law that when you subtract, you divide. So it's going to be log what? X squared over y cubed. Okay, minus log what? Log 100. Okay, again, what do you see? What do you see here? It's a minus that when you subtract, you basically divide. Okay, so that is the quotient law. Okay, so we are going to divide it. Therefore, this is the same thing as log what? Log x. Some of you really don't know how to work out this. I'll show you step by step. Okay, log x y cubed divided by what? Divided by 100. Can you see that? Okay, divided by 100. Now, when you divide, what happens? When, yes, you reciprocate, this one is over 1, you reciprocate and do what? And multiply. Are we together? Because people will not, dividing a number, for example, when you are dividing 2 divided by 3 is fine. But when you are dividing 2 over 3, maybe divided by 5, it becomes a challenge. Are we together? Okay, so you need to put in these basic concepts. Okay, so this is going to be x squared divided by y cubed multiplying what? 1 over 100. Okay, and remember when you multiply fractions, a numerator multiplies a numerator, a denominator multiplies a denominator. So you should be able to know that. And therefore, this now implies that log of that is going to be what? It's just going to be x squared over 100 y to the power of 3. Okay, you take that one to your solution space. That is actually log x squared over what? Over 100 y to 3. Okay, look at that. 4 marks. Then what, isn't it? All you need to know is the laws of logs. Oops, I'm zooming out. So for that.
So,
Yes.
like, is it possible, like, from this answer, like this is like the first one, but like,
As a separate log.
yes,
Yes, it is possible. You can take it there. It is actually possible. You can take it there, right? Yes, we do have a theoretical question there. Says Anna works as a casual worker at a mining company. She works 8 hours per day for 6 days. So when you get these type of questions, you need to read them with understanding. Are you guys seeing? Okay. So when you get these types of questions, you need to read them at least twice or basically once. Okay. So it says Anna works as a casual worker at a mining company. She works 8 hours. Okay. So 8 hours per day for 6 days in your week. And then it says if our weekly wage is 5,400, work out the hourly rate. Okay. So what are we going to do there? Yes. 8 times 6. 8 times 6. And then after you give the Why are you dividing? Oh, you are dividing that one by 5,400.
Yeah.
No,
So I think you multiply.
no, it's the same thing. You are correct, but you are dividing 5,000 by whatever you get.
Yeah.
Yes. All right. So it says Anna works as a casual worker at a mining company. She works 8 hours per day, 8 hours per day for 6 days. How many hours is she working? So it's going to be 8 times what? Times 6 days, isn't it? Because 6 days today, tomorrow until the 6th day, isn't it? So that one would be what? Would be 8 multiplying 6. And then you get what? 40. You get 48, okay? You get 48 hours, isn't it? Now, what she's getting, her weekly wage is actually this. How much is she getting per hour? This is what it means, the hourly rate. That is basically it. So, yes? Mhm. Yes, that is correct. So it's going to be 5,400 divided by what? By 48 hours, okay? And then you are getting? It is, okay? So you are getting basically 100 then? All right. So that is basically it, okay? That is what she gets per hour, okay? Yes, that is actually the final answer. They just want the amount of money she gets per hour. Yes.
So, sir, the 48 days that she works 48 hours in a week.
Yes. Yes. Okay. I think my hands are actually sensitive. You are saying the week is?
She works 48 hours a day.
In a week, she just works for 6 days. And per day, she works 8 hours. Yes. And in a week, she gets that amount. How much money does she get per hour? So it's just that amount divided by the total hours to basically work for. Yes. Those that are online, are you guys getting me?
Yes, sir.
Yes.
Right. Right, great. Now it says 1 week, Anna was absent from work for some hours. Her wage for that week was decreased. Okay. Her wage for that was decreased from 5,400 in the ratio of 3 to 5. Calculate her wage for 3. Mhm. Yes, let's get involved. Yes. 3/5. 3. No, it's fine. It's okay. It's fine. I just want all of us to get involved. I'm not saying you are wrong, and I'm not saying they are right. Are we together? So what do you think? What are we going to do? Yes.
So, I think last time, I don't know what topic, but then like we added the numbers, those two ones, and then like the smaller ones, we put it over the total, like 3/8. So the 3 plus 5 is 8. So
Okay, it's fine. The focus should be right here. Decreasing the ratio. Are we together? The focus should be there. Okay. Yes.
done.
Okay. No. It's fine. All of you are just thinking the same thing. She's actually correct. Are we together? She's correct. Yeah? So, yeah, she's correct. Remember when you are decreasing and increasing the ratio, it's not the same thing as when you are finding a new value given the ratio. It's a different thing. Eh? So if you are increasing, it means that the bigger one is going to be divided by the smaller one. Are we together? And then you multiply. If you are decreasing, the smaller one is going to be divided by the what? By the bigger one. Are we together? Therefore, here we are decreasing. So this one is going to be decreased in the ratio of that. Okay? And therefore, if you are decreasing, it means the smaller one is what? Is 3 over what? Over 5. Then you multiply. Definitely it will be reduced. But if you make it 5 over what? 5 over 3, it will what? It will increase. Are we together? So it's going to be like that, okay? So that one will be multiplying that. Yes. What are we getting? 30? 3,240. Okay. Surprise here is 30 something. Okay. So 3,240. As you can see, the amount decreased. Okay. So it is yeah.
So my question is, zero to they say 1 week. They say 4 weeks. How do you know what that's?
Okay. Let's just attend to the question very well. Okay. So today we have to work as a team. Eh? I like the response. Yes. So it says 1 week Anna was absent from work. Okay. For some hours, her wage for that week was decreased from what? From 5,400 in the ratio of that. Calculate her wage for week 3. Isn't that not week 3? Yes.
So the week that you skip week.
All right. So all right. So let's get it from there. So what is your input from here? Maybe there is the Master Frank. Maybe there is an you have analyzed the question very well.
So what? That's correct. Because we see the context says that 1 week Anna was absent from work, right? And that was decreased according to the calculation.
Yeah.
So we know in that 1 week, be it now in week 1 or week 10 or week, whenever that week. Then the last statement that says calculate for week 3 is with reference to the statement that you started with. So it was decreased, but it was in week 3 that she was absent.
Yeah.
That's what the English means there. So the reason why they say 1 week is because the hourly wages in the previous question was a weekly thing, which means the weekly thing was now 6 days that she working.
Yeah.
So you are calculating. So if you want to know when was she absent, it was in week 3 that she was absent. That's what it means. Yes.
It's with 2.
Yeah.
Week 2.
Yes. Okay. So yeah, we are trying to analyze. This is the first week, and then the week 2, 1 week maybe. But remember, this question is yeah. So we it did not really specify which week was that. So first week, maybe the second week is the one absent, and now we need to calculate maybe the so yes.
So you know what you're trying to say.
They are saying in 2 she was absent. Now they are going to pay with 2, then with 3.
Sir,
Yes.
can I say my opinion, sir? Sir?
Yes, it's okay. I think we are all right.
What is the difference between a salary and a wage? Wage is paid weekly.
Yes.
Right? So
Yes.
that you're calculating is to calculate for the specific week that she was absent, right? So we know that was in 1 week. So if you have to think of, say, adding the first and the second week so that you get the third week, that's not a week.
Yeah. So
Wage is just week.
the answer is correct.
Salary, the answer is correct.
The answer is correct.
So there's no adding or anything because
This-
wage
yeah.
is defined as a weekly payment.
The answer is correct. It's just we now start with week 3, but the answer is accurate, right? So yes, those that are online, are you guys with us?
Yes, sir.
Great.
Yes, sir.
Yes,
Thank
sir.
you. All right. Okay. All right. So it is given that alpha's weekly wage now W varies proportionally to the square root of the sum of the time in hours worked per day plus a lunch hour, which is now x plus 1 squared. Then they are saying when W is equal to that, then x is 11. We should be able to find the equation connecting W and x. So they are saying make W now, we should find the equation or express W in terms of x. Yes. No, they have stated here. Okay, so it is stated here. Proportional, it means is direct. Okay, proportional, it means is direct, but we need to give it understanding. Okay, so it says I think it's fine. All right, so we need to read with understanding, okay? It is given that alpha's weekly wage varies proportional to the square of the sum, of the time in hours she works out together. Okay, remember for direct and indirect, what you need to know is if they are saying that if they are saying that age is directly proportional to M, it's like that. Okay? But now here they are saying that W varies directly, directly proportional to what? To the square of the sum of the time in hours. Yes.
When you say W is equals to X squared, and
Yeah, they are saying is proportional to the square of the sum. To the square of the sum.
So it's a sum x.
Yes.
So it's x squared. W is directly proportional.
Plus. Yes, plus the lunch hours. That is actually that. Okay. So, but some says you should add, isn't it? So what are we going to add there?
so isn't it?
Okay, okay, yes, we have somebody online. What do you think we are going to do?
So I think they're right. It's W, which is directly proportional, which is X, plus
x plus 1 to the power of 2.
Yes, yes, it is correct. Now this sum is not the sum, it's not the sum of the time that we are seeing up there, eh? But it's the sum of what? It's just the sum of these hours and what? And probably z, isn't it? So it is saying that W varies what? Varies directly proportional to the sum of the time plus what? It says now the square, isn't it? So you are going to square that plus x plus 1 squared, okay? But from there we need to generate now the equation. Yes. Yeah. Yes, let's just work on it. Let's just work on it. So I want everybody also to be involved.
So isn't it W is equal to K multiplied by x squared?
Yes,
Plus,
this one is when it's the next step. Is the next, yes, when you are correct, but that one is the next step.
yeah,
Us is to ensure that what we've written down from here,
yes, sir.
it applies to what is said in the problem statement.
Yes, sir.
Is it true?
Yes, sir, it is.
Yes, Master Simba.
I think it should be W is directly proportional to the x plus 1 squared. Yeah.
X plus
X plus 1 in bracket or squared. That's expression that was given here.
x plus 1 squared.
Is x plus 1 all in bracket squared. So in other words,
Okay.
directly proportional to x plus 1 bracket squared.
So what about the x squared?
You already said plus the lunch hour. Is it plus 1 way in the bracket? So that's the lunch hour. Is it not? Yeah.
Isn't this not correct?
Okay, Master Simba, just come help me out here. Yes. I think you can see very well from here because here. So here, yes, I'm saying the W is directly proportional to the X bracket plus 1 squared. Like that. Because here they told you this is the X, this is what we don't know. And then they said plus the lunch hour, which is this here. Yeah, all of that is squared. Does that make sense? Okay. Sorry?
I'm gonna ask a question.
A lunch hour is just 1 hour. So it's in hours. They said in hours, X. So all of that is squared. Square of the sum of the time in hours, X, plus the 1 hour, which is all in brackets. Yes. Sorry, what is it?
So the reason why I'm saying it's with this because they're just showing us the hours and things.
Yes.
And then the other side, the
Lunch hour.
lunch hour.
All right,
Sir.
great. So this is the expression that you're supposed to.
No, I disagree.
You disagree?
Yeah.
Why? Yeah,
What
but,
happens, what happens to the x squared, sir? So the question is even asking, it's even saying that it's work per day plus a lunch hour.
What per day?
Yeah, plus
Right,
a lunch
look.
hour.
Okay, let's start again. Read the question. W, right, varies proportionally to the square of the sum of the time in hours plus the lunch hour day. So that sum we've already added in this bracket. Can you see that? The sum we're adding. Yeah. That plus. Yeah, I think it's correct.
It's correct.
Yeah, I believe it's correct. Yeah. Downward.
I want Mr. Magunda. He knows.
Yes. Can I explain it another way? Come.
Your imagine it's just 4 marks.
So the same with W. Let's start here. It's given that Alpha's weekly wage is W. Yes. If you come here, the time in hours is X.
Yeah.
Why did you not say W squared? Yeah, why did you not put W squared? Now check over now. It's W. Here is the square of the sum of the time in hours X.
Yes.
Work per day plus a lunch hour. You already put what the time is.
Yeah. That's the one
Plus
per day.
the lunch hour where the square comes in now here.
Yeah. Does that make sense? And so they literally describe everything here and put it at the end. So just circle from the X.
Thank you, you are right. You are right.
Yeah.
Yes, class. I believe we also have to meet time. Otherwise, we have to fight against ourselves. Yes, sir.
That question it's very important because when we use context in the English, it's not per se coming up with the expression data getting into the equation. It's the English there, and it's very common, especially if you are having a word sum, for you to come to the expression or the equation from the word sum. If you properly understand English, you would have it as W is directly proportional to open bracket X plus 1 close bracket square. That's the correct one because there we say W varies proportionally to, then it starts to explain the right hand side of that thing. Or you see that? To what does it vary? To the square of the sum. So there is a sum. So to the square of the sum. Just put the brackets. Just the brackets, only the brackets. No, without anything inside. Just close the bracket and square the bracket. Okay? Look, just close the bracket and then you square. So whatever is in the bracket, that sum of that square. You understand? That's what the English says. Very proportional to what? The sum of the time which is given in X, right? And then work per day plus the lunch hour. So that X is work per day plus the lunch hour is represented by the 1. So the sum of the X and the 1, that together is squared. So that's the case. If you expand that bracket, you will get X squared plus 2X plus 1, right? Introducing the constant. And then you will see, even if you solve that quadratic equation, you might have your X as a positive or a negative, but in this case, they already give us the X and the W, which means you'll just find your constant that you're introducing it. Even if you are confused the other way around, right?
No, I'm fine with it.
Okay.
Yeah, I'm fine with it. It's just that everything that is done on this question is provided. That is basically it, but I'm fine with it. I understand it. Yes.
So I think one way to get if you push 15666 and W and we try to work it out, it must give us 11 without the X squared.
It's fine. Everything is okay now. Everything is fine. Okay. Are you guys fine online?
No, sir.
Yeah.
Okay. Therefore, yes, it is the way it should be. Yeah, I believe now we can just work out and find the equation. Yes, because
Swain is getting confused after the X comma. Yeah. He's taking it as two different statements. It's not two separate statements.
that is actually what I
Sum
also
of our X, right? After the comma, it explains what that X means. So the work that you've done per that day is representing your X plus your lunch hour. You understand? So don't take it as two separate statements. That's one statement that just represents the work per day. Even the explanation Mauritius gave from the other side also makes it clear.
Okay, sir, I agree.
All right, sure. Okay, so now everything is fine. Everything from here, I believe, is now easy. When you put it now in the mathematical representation from the word problems, it's fine. You can now be able to come up with the equation. Okay, therefore, it is basically direct proportional. You introduce now the equation and your k. Okay, so therefore, this one will be k x plus 1 squared. So our aim, our objective is to look for A, to find the value of A, because they've given us the value of W as well as the value of X. Okay, so this is basically 666 equals what? K, and your X is actually what? Your X is basically 11, right? Plus 1 squared. Okay, so this is actually 666 equals K 12 squared, that is 666. I think it's 144. Okay, what are we going to do next? All right, so we are going to divide by 144 on both sides. And what is the value of your K?
4.625.
4.625. Okay, 4.625. Right. Yes. Okay. Now, therefore, express W in terms of X. Therefore, it's going to be then. All you need is going to be, what is your K? Is 4.625 of what? X plus 1 squared. So that is what you take there. Okay. Now it says that work out alpha Suki hours when W is basically 1,498.5. So we need now to find the hours of bed. So what we are going to do is we are provided this, and you know the value of X is what? The value of X is some hours. No, it's not 11. It's just time. We are going to find the time. That's why they are saying what? X is hours then. That's why they are saying we should work out what? Alphas, weekly hours. Okay? So we are just going to, you know, the equation is basically W equals 4.625 of what? X plus 1 squared. Okay. And therefore, you are given already the value of W right here. So it is actually 1,498.5. Okay, equals what? Equals 4.625 X plus 1 squared. What are you going to do? Okay, you are going to divide by 4.625. Okay, you divide by 4.625. This cancels out, and then what are you going to have? 324. Exact. Okay, equals X plus 1 squared. Now, what are we going to do next? Okay, so we have to apply the square root. Okay, but on this side, you will say plus minus what? That. Okay, so This cancels out. And then here you have what? 18. Okay, so plus minus 18 of what? X plus 1. Eh? So what are you going to do? You are going to bring this one exactly where? Right there. So your x is going to be what? Is going to be negative 1 plus minus what? Plus minus 18. Eh?
Plus minus one.
Come again?
So why is it?
So I moved the one on the other side and it became negative.
For the 18, so why is it plus minus?
It is plus minus because of this square root. It will still be.
So,
Yes.
in the square root of 324, why is it plus minus? Why can't it just be square root?
Okay, okay. Remember completing of the square. Eh? I've been trying to answer you now. Completing the square. Suppose maybe you're having x plus 1 squared equals 16. Are we together? Just look at this for now. And then you apply a square root here. Here you will say plus minus what? Square root there. So this will cancel. It will be x plus 1 equals what? Plus minus what? 4. You will still take this one there. The plus minus will remain. Are we together? So it's going to be x equals what? Negative 1 plus minus 4. Because it is what? The plus minus is staying because it has two solutions. It is a quadratic equation. Yes.
So what is correct? But then you're asking how much it how.
You know, it is negative.
We are going to find the value later on. Are we together? So we are going to find the value later on. Okay. So we will have two solutions. Eh? One of them will be positive, one of them will be negative. It's like when you are working with logs, you are going to have two solutions, one negative, one positive, but logs only work with positive answers, but you have two solutions.
So, the final answer is
Yeah, we are going to find the final answer now. Yes. Just bear with me. Right. So it means one of your x is going to be negative 1 with a plus 18. And then the other one is going to be x with a what? Negative 1 with a minus 18. This one will be what? 17, and this one will be negative 19. Because of time, we'll only have the positive one. But you should, what if it was saying, just solve for x? Definitely, if they didn't say it's time, they were just saying solve for x. Definitely, you are going to have two solutions because of what? Because of this. You are going to have two solutions because of this. It is a quadratic equation and it has two solutions. Are we together? Yes. Okay, it's just now we know what you are finding, that is time or distance. Those ones will never be negative. Yes. So the only answer here is actually 17. Okay. Yes. Thank you. Don't stay so much. It says a box of sweets has dimension 5.1 centimeter by 8 by 10.5. All three measurements are correct to the nearest millimeter. Okay, so it says calculate the least possible perimeter of the shaded cross section. Okay, so what are we going to do? What are we going to do then? Yeah, it is upper bound and lower bounds. But what are we going to do now? What will so its perimeter is not it's basically not volume. So how are we going to attend to that question? Yes, that is the first thing that I want. Just raise that one. Those that are online, are you guys hearing me? Are you guys hearing me online?
Yes, sir.
Yes, sir.
Right. So
Yes,
what are we
sir.
going to do first?
So first we're going to be converting the centimeters.
Yes. Yes. Okay, but let me just see the answer that they have it in what? Maybe they have put some measurements there. They put centimeters there. Therefore, we are going to convert centimeters to, millimeters to what? To centimeters. But what you have said is correct, it's just that we didn't check here. So they want our final answers to be what? To be in centimeters, right? So one millimeter is equal to how many centimeters? 1 centimeter is equal to how many millimeters?
What's the question, sir?
So we are going to remember this one. They are saying that all three measurements are correct to the nearest what? Millimeter. Are we together? Okay, it's correct to the nearest millimeter. Now we need to convert, but when you look at this, this is centimeter, it's not millimeters. Can you see that?
The decimal numbers are
No. What do you mean the decimal numbers? Like this one?
This times 10.
Which decimal numbers are taken?
The one is not the 1 millimeter. If you say 51, then the one.
It's 5.1. No.
0.1 is 1.
So okay, what is your input? Yeah, 1 centimeter is equal to how many millimeters? 1 centimeter is equal to how many millimeters? Is equal to 10. Yes. But what he's saying is that this decimal is the one which is a millimeter, which is not true. Are we together? This is just centimeters. Okay. So that is basically not true. So what we are going to do is basically the first thing is to convert what is to convert from the millimeters. No. No, the answer is basically in centimeters.
Because put it in millimeters, it will be converted. Because we have to round it off to millimeters.
All right, great, great. Remember what I want us to do. The upper bound is always something that you are going to divide by 2, and then you add it somewhere, and then you subtract it somewhere. So we do not want to convert all this to millimeters and then basically come back again. No. So our aim is to convert, because they say correct to the nearest what? Millimeter. Are we together? It's just to convert this millimeter to what? Basically millimeters, which is equal to yes. So basically, 1 centimeter is equal to is equal to 10 millimeters. Are we together? Okay. So basically, we know that you are having what? You are having 10, So you are going to divide 10 by what? You are going to divide 10 by, you are going to divide 10 by 2, okay? Yes, you are right. Yes, you are basically right. Okay.
Please, so make a list. So we can see from the side. And make the page a little bit bigger. The plus sign is, bigger.
Yes. All right. No, I basically understand. I've gotten it. Okay. So I've gotten it. So it means 1 centimeter is basically 10 millimeters, isn't it? Okay. And then 1 millimeter is basically what? 0.1, right? It's going to be 0.1. Therefore, we are going to divide. Therefore, we are going to divide 0.1 divided by what? Divided by 2, and then you get 0.1. You get 0.05. Yes, 0.05 centimeters. Okay. So basically, now we have a long way to go. We have a long way to go because they are saying you should be able to find what? To find the perimeter, the least possible perimeter of the shaded cross section. Okay. So what we are going to do is basically to work on this one only. Okay. So we want to find the perimeter of it. Therefore, it is 8 centimeter by 5.1 centimeter. Okay. So I will make use of this space. All right. So this is 8 centimeters, and then basically 5.1 centimeters. And then here is your lower bound. And then this is your upper bound. Okay. So if we divide, if we basically subtract 0.05 from that, what are we going to have? 7.195. And then basically if we add 0.05 to that, you get what? 8 point. Oh, sorry. Okay, that is basically for the upper bound is going to be 8.05. Okay, so those that are online, are you guys fine? So and
Yes,
then
sir.
we move on to the other side. So this one is done. So we move on to the other side for finding the perimeter. I mean the estimation of it. So if you remove, if you basically remove 0.5, I mean 0.05 from this, what are you going to get? Yes, 5.05. And if you basically add 0.05 to that, what are you going to get? 5.15. Okay. Now we are going to have I forgot it. The 10 point. Oh, yeah, it is this one. All right. So they are saying find the least possible perimeter of the shaded cross section. Now we are going to find the perimeter. Okay, we are going to find the perimeter. The perimeter of this and that. So what is next from there? Perimeter. Remember, you are going to add this. And now the perimeter you are going to add. Remember, this ones are 2. Even this is there twice, isn't it? This one is again there twice. Are we together? So you are going to multiply by 2. Okay. So for this one, I will redraw it here. It's not a square. Yes. Okay. So this side, we are having 7.1.95, and basically on the other side, you are having what? You are no. You are having 8.
Sorry, I think 5.45.
Yes, 5 points. 5.05, all right? So you are having 2 of them, eh? Okay, you are basically having 2 of them. So which one is going to give you the maximum perimeter? Is it when you add the upper bounds together or the lower bounds together? So which one will give you the most? Okay, the upper bounds will give you the most, but which one is going to give you the least? Is basically the lower bound. So what we are going to use, we are going to use the lower bounds for us to get the least. Okay, so this one, it will be what? We are going to have 2 multiplying what? Multiplying 7.95, and then plus what? Plus the other lower bound again, 2.
So the easier way is just add and then you get the answer. And it's 30 times 2.
Yeah.
What will happen if they ask you I don't know whether the follow-up question is the maximum area. What will you do? You're just gonna multiply
Okay.
the upper bound.
Yes.
What are you gonna do? Will that give you the maximum? Please look out for that. Once I just think, I'm just going to multiply the upper bound.
So what is 20? 26. Exact. All right, so basically that one is the minimum, but if you use the upper bounds, all of them, you multiply this by 2, this by 2, definitely it will give you something which is more. So this is actually it. Yes, the greatest possible volume. So for volume, there is still another, there is basically a side which we have not estimated. Okay, so the estimation of this, are we together? Because we need to multiply this, and that. But the other ones we have them, isn't? The other ones we basically have them. So we still need what? We basically need again to, yes, I'm going to use this space. So we basically need to use again what? So we will have to use that 10.5, okay? So if you basically remove, you are going to get what? You will get 10.4. Yes, okay, and then basically I told you say 0.4. Okay, so if you add, you are going to get what? If you add, you are going to get what? 10.55. Okay, so basically, yes.
Because volume is not like cube.
Yeah, it is. We are just sorting out the estimations for now. Okay, so we are sorting out the estimations for now. So because they are saying, the greatest possible volume, volume is just length times breadth times height. Therefore, we are going to use the upper bounds. Are we together? We are going to use the upper bounds of all sides. The upper bounds of what? The upper bounds of this, which is what? Which is this times that, isn't it? It will give us the greatest of all. Okay, so yes, so this one maybe I can zoom in. Okay, so the greatest volume is going to be what? 8.05 multiplying what? 5.15 times 10.55. Okay, and then you use your calculator to get there. Yes.
When do you know whether you should make the upper bound?
By if they are saying the greatest. Remember when I have drawn this. Remember when I have drawn this. Suppose, okay. So you are having two of them. Okay, you are having two of them, right? Now, when you have when you have made now your estimations already, remember you are going to have what? You are going to have a lower bound. Okay, a lower bound here. Remember, this is 8. Okay, so you have it here 8 and 5.5. What is the estimation of the lower bound of this? Is going to be 7.95, and the estimation for the lower bound of that is going to be what? Is going to be 5.05. Okay, but the other one again, the estimation again. Okay, the other one again is going to be what? For the upper bound, we just have upper bound. This is all for the lower bound, and this one is for the upper bound. This one is going to be what? Is going to be 8.05, and this is going to be what? Is going to be 5.15. Now you say, how do you see that you're going to use the lower bound or the upper bound? If the question is saying that which one gives the least perimeter, definitely it's when you add the lower bound together. And which one will give the most perimeter? It's when you add the upper bound together. Okay.
Look, Mauritius, what you are asking. Sometimes you can have a situation where they ask in terms of distance, for example. There is a table that you can follow for distance. But when it comes to mensuration, like perimeter area volume, it makes sense. For example, for you to get the greatest volume will be the product of the upper bound area and the upper bound height. Volume space plus the height. That would be right. That's the logic behind it, and that's the correct one if you are dealing with this. But you have other options that sort of like is an inverse relationship between them. I remember even Kukuri, you had this question once, and I said, Miss has a table that she explains that very well. Maybe we could get a question that can clarify that with a table so that you can know when you would use that in that regard. The good news is Miss is done with her stuff, so she will join us from tomorrow until we write the maths. So you know that I always tell you that there's no one that I have seen so far that teaches this maths basic things as good as she does. Yeah, so she will be here tomorrow. The idea was for us to look at different question papers. We as teachers have seen the paper you wrote, right? The only problem we have with it is since the whole thing is under investigation, we are a little bit too careful to discuss that paper with the class. You understand? We don't want to do that because I think if there was no issues with the investigation, what to use the paper. So we will use other papers that would be similar to that. It's also just to protect ourselves. We never know what people say, those people they did so well because we do well because we work hard. Yeah? You understand? Yeah, so Charles, that answers your question. Yeah? So if you happen to get the paper somewhere, that's fine. But no. Charles asked the question. He asked the question if we can get a copy of the math papers involved. So as teachers, we actually have to comment 2 days after you write the paper. Was it fine? Was it not good? Was it too sharp? So we have access to the paper, right? And we opt not to be involved in. So let's use other papers that we can work with. And I think keeping to the academic papers is the best. All right. So from tomorrow, listen. Hey guys, the reality is next week Monday we write. So I'm even thinking we must even get extra time just to go through question papers. We work through the question papers. Some questions we can go a little bit faster than others so that we don't explain too much. The problem was we initially wanted to get to the copies of that paper, but we just decided not to do it. That's why we didn't print this paper. Yeah. So we would print papers from tomorrow that you sit with, and then we work through that. So if everybody agrees, don't say, let's skip this question, it's fine. Then we go to the next question. Then go to the next question. So that we can get as much as possible. Yeah, done. Okay. Yes.
So we're gonna do this next week again.
Yeah, Mauritius wants to do it. He says we can't cope without it. So how is Saturday?
So this week, we know what is.
Friday, then Saturday.
No, Saturday we can, yeah, let's do it Friday. Is that okay? So we write a full exam Friday and then Saturday we give feedback. Is that okay? Yes.
All right,
Okay, so guys, please put the chat